Okay, welcome everyone. The next session is presented by Shubha Vijayasarathy. She is a Senior Program Manager for Azure Core and is responsible for the messaging services, Event Hubs, Service Bus, and Relay. In her session today, she will give us an update on what is all new with respect to Event Hubs. Shubha, you can take over.
Thank you, Mohan. Good morning, good evening, good afternoon, everyone. My name is Shubha Vijayasarathy. I am a Senior Program Manager with Azure Messaging Team. Azure Messaging Team has four core Azure services: Azure Event Hubs, Azure Service Bus, Azure Relay, and Azure Event Grid. And I focus completely on Event Hubs. Today in this session, I'm going to talk a little bit about streaming, Kafka, why Event Hubs for Kafka, and what's coming up for Event Hubs. Before we get into the details, I have some interesting statistics. If you look at what enterprises are doing today to increase their customers or to increase their revenue, they are integrating with customer analytics. They are trying to move towards everything that is customer, improving the customer experiences, personalizing for customer, and personalizing it in near real time. So these statistics are got from Forbes. These talk about when they do this change, what are they kind of seeing, or where is the increase that they're seeing. So let's take, for example, what that really means. Most of us would have used some kind of a ride service. Here I'm taking Uber as an example. It could be Lyft, it could be taxi, it could be any ride service that's there available in your local to your area. So it's as easy as me opening an app on my phone, clicking on my, or giving the destination where I want to reach, and in couple seconds I get the instant notification of, hey, this is your ride, this is how far the ride is, this is how it's going to cater, or this is how much it's going to cost, what is the preference of my ride. So if you live through that experience, while it's not just near real time, it's so much catered to me, my personal ride. So even when I get onto Uber, it's talking about what is the fastest route on my destination, what is some of the traffic updates that I would be worried, or I would be influenced by. What are some of the instant traffic route changes, all cater to me, so making me special. So at this point, when I'm using Uber, I'm not thinking about what are the features that Uber provides, but I'm just happy that Uber is taking care of me as a customer. So what I'm trying to get with this is the data that we were talking about. We are now moving from data-driven focus to customer-centric focus. So we are clearly moving from the world where data was at rest and all we cared, or all we focused on, was storing that particular data, protecting that data, and once we move on from preserving the data, we would then care about analyzing, getting the insights, and then dealing with the data. Now we want the data in near real time. What does that mean? We want data which is in motion. So rather than preserving or storing and protecting the data, we want to respond to the events. We want to respond to the events in near real time, and we want to do that as fast as we can. So we see the paradigm being shifted to an event-driven focus, where we want to get the data where it needs to be there, even before it needs to be there. So we want to be as responsive as possible, and also cater to the personalization of customer. So it's all about the customer experiences and how quickly I can cater to that particular customer experiences. So how do we achieve this? This is where the data streaming platform comes in. So the data streaming platform sits pretty much like a backbone. We know that we need to get the data. We are interested in that data and we want to get that data out there, analyze, get some actionable insights, uh, get back to the customer or respond in near real time. And how is this possible? This is possible because of the streaming backbone. That's where Event Hubs, Azure Event Hubs, or Apache Kafka sits in, where these intelligent applications like Stream Analytics, like Azure Databricks or Apache Flink, which are capable of producing that actionable insights on the data. Or look at the data that's there on the left-hand side, where this is all about customer getting those, the Uber routes or traffic updates. So from one point to another point, you are depending or completely built on top of your streaming backbone. And that's pretty much where Event Hubs or Apache Kafka comes in. So what are we looking at in a streaming platform? So you want that highly available platform for your data to be always there. You want a low latency so that you get the data from point A to point B in near real time. You want to cater to scalability. You want to be able to go small when there's less data and just fan out when there is a lot of data. You want to be able to take action in near real time and be able to replay. You want to be able to persist the data. You want to have immutable events, and you want to process the data not in sets anymore. We are not talking about big batches of data. We are talking about individual events, small discrete data that comes in. And this is where this is exactly the platform Apache Kafka or Azure Event Hubs provides you. It caters to wide variety of producers, heterogeneous producers, and then it caters to scaling on consumers, and it lets you parallelly consume so that you are having a lot of consumers consume all the data at the same time without competing with each other. And this is the platform that it gives by using partitions, by giving a big buffer, a big pie that you're able to stream through a streaming platform, a perfect streaming platform. And if you see the architecture of both Apache Kafka or Event Hubs, it's apples to apples, pretty much the same. Like both are a streaming platform, both are built on partition consumer model. You both cater to heterogeneous producers, both cater to multiple parallel consumers. So what is that? We keep talking about Apache Kafka, and what is that we get from Kafka? Kafka is an open source software. It's pretty famous because it has a community. It's open source. Everybody loves open source community, open source software. And what does Kafka give you? Kafka gives you all this capability as a software. You download that, you install that, you download and install, and then you manage and you run. Along with that, Apache Kafka also gives you a real rich ecosystem, like wherein you have tools like Mirror Maker. I have a small demo on Mirror Maker, on Apache Kafka Mirror Maker later on, which is helping you mirror your data. You have Kafka Connect, which is a framework which is built on top of Kafka itself, which lets you connect between your sinks and sources. And we are talking about things like file systems, like SAP systems. You have Kafka Streams, which lets you aggregate on the insights or on the data that's coming in. And you also have pluggable or plugin connectors to Spark and Storm, which lets you analyze on your incoming data. But what is with Kafka? If I look at what I have to do with Kafka, I need to, it's a software I need to install. It's an open source software, but that's about it. I need to procure the hardware. If I want to run the Kafka, if I want to have such a streaming platform, I, as a customer, am responsible for all that I need to deploy. Like I need to procure my hardware, I need to install my network, I need to be worried about my compliance, my security. I need to also install my OS. I need to keep my OS up to date. So it's not just the deployment one time and forget it, but it's also the management that continuously keep happening. So that's where, since Event Hubs is nothing different from Kafka, we wanted to see how we could integrate Kafka. We do have a big base of Event Hubs customers, but then we also wanted to see how we can cater to the open source world and embrace Kafka. This is what, and this is the approach that we took for it. So, like I said, we love Kafka, we love the software, we love the streaming platform that Kafka provides, but we do not run or host Kafka. So what we have, the solution that we have is completely homegrown. So we are a multi-tiered architecture built completely on Azure services. What that gives you is the inbuilt security, the inbuilt reliability, the inbuilt time-tested platform, which on top of which Event Hubs itself runs. So we do not host Kafka, we do not host any Kafka brokers. The way we have approached Kafka is by putting a protocol head, taking the protocol specification, and since architecturally both Event Hubs and Kafka are the same, we have completely mapped one-on-one on the protocol end or on the binary protocol level, because underlying, if you see, Kafka and AMQP, which is the native protocol of Event Hubs, both use the TCP protocol. The advantage that this approach gives customers is that it's an open API approach, wherein customer is concerned only of using Kafka protocol and not on what technology it runs, because it runs solidly, it runs the way the customer expected, it runs in a way it's eligible for or capable of handling production load. So customer is only concerned about the APIs. It's not about the technology on which it runs. It also gives us an advantage where we don't have to go and support every version. We support the protocol itself. That means any version beyond, I know that we started from version 1.0 because we wanted to support TLS, and Microsoft enforces TLS on all Azure services. So any version above 1.0 of Kafka just works fine with or on Event Hubs. Underlying, both the protocols use the same broker engine, and this has helped the customer now focus on the application and focus on building the business rather than focus on any kind of infrastructure that they need to be. So why Azure? Because our approach is to simplify Kafka. Event Hubs is a completely managed platform as a service, and integrating Kafka, we give the same experience that our native Event Hubs customers experience. It's a complete managed zero code setup platform. And you can start with Kafka as low as 1 MB and go up to a couple GBs. Now, I'll show you when I demo Mirror Maker how you can ingest the data that's in your Kafka cluster in your on-prem onto cloud with this integration. So you can easily, it's an easy gateway to get onto cloud. Not just that, because you're on cloud, we spoke a lot about the Kafka ecosystem and the various tools that the ecosystem provides, like Apache Flink, Apache Storm, Apache Mirror Maker. The same thing you get from the Azure ecosystem. Now, you don't have to do anything extra because Event Hubs is already integrated with Azure Functions, Azure Logic Apps, Azure Stream Analytics. So you are kind of marrying the both the ecosystems. So customer now has wider choice. Plus, since they're using the same Kafka protocol, it makes them cloud agnostic. Because today you take the same application, same setup, go to GCP or AWS, change your configuration, and you run, because it's the same Kafka protocol and Kafka applications that you're talking about. So it's a gateway to this cloud. It's cloud agnostic. You are not bound by the underlying infrastructure. Plus, you get the Azure Essentials by default, like you get all the security, all the compliance, all the availability, all the features that's mandated, like bring your own key or VNet or IP filtering or private endpoints, all these by default. And this is the biggest advantage that you see by integrating Kafka applications with Event Hubs. Not just that, since we support this from a binary protocol stack perspective, the interoperability, where an application, a producer application talking Kafka while ingesting, can simply talk AMQP while it's egressing or consuming on the other end. So the interoperability, where you don't have to depend on just one kind of protocol, is also gone. So you have a lot of advantages, and also in a simplified way. And that's the kind of approach that we are taking with this integration. So how easy is it to set up such an experience, such a PaaS experience? All you have to do is go to the Azure portal, click on creating a resource, and you create an Event Hubs namespace. Moment you have an Event Hubs namespace, it gives you an endpoint. So that endpoint in Kafka world would be your broker IP. So an endpoint where you can use to talk to or connect to Event Hubs. And that's pretty much it. You then, as you can see here, I have a very simple Kafka producer application, where I'm not doing any changes to my code. This is a Java Kafka producer application. It's a simple application. And in my config file, all I'm doing is I'm changing, instead of pointing to the brokers, the broker IP, I am just changing this to point to my namespace name, which is the Event Hubs namespace name, which gives me the unique FQDN. Now, normally Kafka is open on port 1992, but for security, for us to be more secure, we are opening it on 1993. These are the only changes that you need to consider. And then this is the connection string, which gives you the required essential credentials to connect to this particular namespace. And this is pretty much it. You start streaming on Event Hubs the same applications that you were using to stream on your Kafka cluster. The next one is a demo where I spoke about Apache Mirror Maker. Apache Mirror Maker is a Kafka tool that simply copies data from between Kafka clusters. It is like normally in a event streaming platform, what we see is a producer producing and consumers consuming, and producers and consumers are disconnected. Like, I don't know who the producers are, I don't know who the consumers are. I just talk to my streaming platform. What Mirror Maker, you can think of Mirror Maker is, I'm sorry about that. So you can think of Mirror Maker to be a simple connector between your producer and your consumer. So once you have your Mirror Maker tool set up, it will connect your producer from one of the Kafka cluster onto the consumer into a different Kafka cluster. So you copy the data into different Kafka clusters, and then you can start consuming from the second Kafka cluster. So let me start the demo and explain as we go. So here, this is the usual Azure portal. I already have a namespace called Kafka Playground. And here is my topic. Mirror Maker 1 is my topic. And I'm going to copy the connection string that I need to connect the essential credentials. And as you can see, this Mirror Maker is empty. Like, this topic has no data in it. And these are a couple configuration changes I'm doing. I have Kafka set up on my local box. So I'm running Kafka cluster on my local box. I also have the Mirror Maker tool, and the Mirror Maker tool is also running on my local box. I'm trying to connect or give the connections on my producer and consumer configurations and my Mirror Maker configuration to connect to the Event Hubs namespace. This is pretty much what I'm doing, and to connect to the Event Hubs namespace so that my Mirror Maker kicks in to replicate my topic, which is on my local Kafka cluster that is also named Mirror Maker 1, and starts replicating the data into the Mirror Maker 1 topic under my Event Hubs namespace. So it's pretty much as simple as that. So all you're seeing here is I'm getting my configuration ready, and now I start my consumer app, which is consuming from the cloud. So I have my Mirror Maker already set up, which I'll start showing you. This is my producer, which is producing to the topic, which is on my local cluster, and Mirror Maker is replicating the data from that topic onto the Mirror Maker topic in my cloud. It's as easy as that. So this is my Mirror Maker. I start running everything, and my right-hand window will start consuming. This is the data that it's consuming from Event Hubs namespace, Event Hubs topic, the topic that we had under the Event Hubs namespace. The data is being pushed from local Kafka cluster, which is like an on-prem Kafka cluster, which I'm running on my local box. And the way Mirror Maker works is it tries to replicate the topics which have the same names. Like, so I have Mirror Maker 1 on my local cluster, on my on-prem cluster, and I also have the Mirror Maker 1 topic under the same name in my Event Hubs namespace. So that's pretty much how it maps, and it just replicates. Now the demo gets into an interesting mode. Now all you're seeing is running consumer from my topic. As you can see, this is the consumer group that I'm running from. We are also going to see pretty soon how the same data, which is there, which is just been added to my topic in the cloud, and how I can use the Event Hubs client to read that data and start consuming. So this is what you're reading from the Kafka consumer, and this is a simple consumer. This is a simple Event Hubs consumer. So this doesn't know any Kafka. This is just reading. I'm just giving my Event Hub name, which is also the topic name, interchangeably, and my connection string and my Event Hub name. And all I'm doing is, this is a consumer, C# consumer that I'm running using AMQP to read from the same topic on the cloud. So the interoperability just magically works. So this is the big advantage that you get with the approach that we have taken. It's an open API approach, and you're bringing both the worlds, both the open source world and the Azure world together. So I hope everyone enjoyed that demo. So moving on, we spoke about Kafka, we spoke about Event Hubs, we spoke about how both are integrated. I want to shift the focus a little bit and go towards what are we offering with Event Hubs. So Event Hubs today comes in two flavors, or comes in two SKUs. We do have a basic SKU, but basic is super basic, so I'm kind of ignoring that for this argument. Where we see most customers do their production load is in Event Hubs standard SKU and the dedicated SKU. And what's the difference? So standard is multi-tenant SKU, meaning assume we have a massive cluster where we slice and dice the CPU and memory of each of a part of that cluster and hand it over to each and every tenant that that uses or that is on that particular cluster sharing the resources. So because we do this, we kind of share the resources, we enforce a lot of quota. And there is only a certain limit that we let our customers grow to. So that's the reason we have standard with a lot of limits, a lot of quotas. So, like you can grow only up to 20 TUs, and on very exceptional cases, we let you grow up to 40 TUs. You have, I'm sorry, on the number of namespaces, you have 10 namespaces. This is a typo here. So you have 10 namespaces. Sorry, I thought this was the event types. So you have one namespace. For each namespace, we deal with namespaces in standard. So for every namespace, you have 10 event hubs or 10 topics per namespace. You also have the way the billing structure or the billing model is based is that you not only pay for the throughput, which lets you or which decides how big your pipe is in MBs per second. You also have to pay for every million events. So there are two units that you need to be bothered about or cared about or concerned about. You do have limits on the partitions, you do have limits on the consumer groups, you have a limited number of broker connections, all this because we can only share part of the resource without bringing or without bothering all other tenants that are sharing the resources. So and also capture is an extra meter that goes over on your standard scheme. When we shift our focus onto dedicated, we did this because most customers wanted, single tenancy because, and also they had huge enterprise needs like beyond 50 MB per second or and up to a couple GBs. So it made more sense than being in a shared resource to build capacity-oriented resource, and that's why we have single tenant dedicated clusters. What the single tenant dedicated cluster gives you is an umbrella for all the namespaces that can be. Behaviorally, once you have a dedicated cluster and you go to the namespace level, it is the same kind of behavior, the same service that you would experience in a standard queue. But the thing is, the biggest thing that you see is the limits are lifted, and these limits that we enforce are more like soft limits to enforce best practice, because you don't want 1 MB per second being ingested into dedicated, but you open 500,000 connections just for that to bring the whole cluster down. So these quotas are soft limits at this point just to enforce some kind of best practices. This also mimics the exact behavior of the Kafka cluster. If you're looking to compare your Kafka cluster, which is on-prem, on with your dedicated, on with what's the equivalent to my Kafka cluster on event hubs. Dedicated cluster is the way I would say you would want to go, because there's no limit on the number of topics or number of event hub instances, whereas in our standard, the number of topics are strictly or stringently limited to 10 per namespace. We also have extended retention. We also have other security features like bring your own key. And in future, when we add more and more valuable features, it would always cater to the bigger cluster or the dedicated cluster, because that offers the compute and offers us the leverage to play or have the features added with the compute that it comes with dedicated clusters. So while we limit the bandwidth, we give you the throughput guarantees of, hey, you booked for 20 throughput units, so you get 20 Mbps in and 40 Mbps out. We do not charge on the egress, but we let you, we put a limit on how much you can egress as well. You can go only 2 times how much you have ingress in standard. Whereas in dedicated, it's your cluster, it's built for you. You can ingress and egress at your will, how much, I mean, depending on how much you can utilize that cluster. So on those terms, these are a couple of our benchmark results uh, on what we have seen with dedicated. So here, let me walk you what we have done is we have tested this. This is a 4 capacity unit dedicated cluster. Dedicated cluster comes in capacity units. Each capacity unit is capable of, on an average, doing 100 Mbps. But since this is a streaming platform and there are various ways, there are various permutations and combinations that you can do with your producers and consumers. Like you might have 5 producers, but you might have 100 consumers. Your payload might change from being just 1 KB to 1 MB. So there are different combinations of things that you can do with streaming platform. But here, for our benchmark purpose, we have taken a 4 capacity unit cluster, and we have tried with 3 different payload shapes at different frequency, and try to see how much we can get. And this is a very common mistake that customers do, where they ask, how many TUs can I get per capacity unit? How much throughput unit can I get per capacity unit? So there is no relationship between throughput units and capacity unit. We provide throughput units, and we give you that guarantee with throughput units because we control, like we let you only ingress based on the throughput units that you have selected on your standard. But when it comes to your capacity unit, it completely depends on your streaming patterns and how optimized you can utilize your cluster. So this TU, what we have mentioned here, is just for referential purpose only. So what we have done is we have tested with 1 KB, and we have sent those in 100, batches of 100 each. And when we did that, we saw an ingress of 400 MB. This is a 4 capacity unit cluster. This is not a 1 capacity unit cluster. And hence, we also have receiver. This is a combination of I'm ingressing so much, I'm egressing so much. So when we do this, a plain simple batch, we saw 400 MB ingress and 800 MB egress. So pretty much 100 MB on an average. And that's how I would also try to, take my 1 capacity unit cluster would be. To optimize, we also tried these 2 samples, and when we optimized our batches with bigger payload size, we were able to achieve more capacity. Like just by batching in 10 KBs, we saw a bigger bandwidth, bigger ingress and bigger egress bandwidth. When we batched it at a higher payload, we saw even more optimization. So there are various ways of optimization, but on an average, I would say each capacity unit can do anywhere between 100 MB per second to 200 MB per second. We let you go up to 20 capacity units. That's the highest that I've seen customers do. But beyond that, also we could think about. So, but these are the various options that we have with dedicated. From here, the next few minutes, I'm going to talk about our roadmap or where we are heading. So earlier this year, we launched a bunch of things. We had the support for bring your own key. Like I said, there are couple security features and potential features, or very valuable or very expensive features that we would be catering only onto the dedicated clusters, rather than just giving on the standard or on the standard namespace. Mainly because it's single tenant and it gives the resource that we need to provide more such capability in a full-fledged way. So bring your own key or customer managed key encryption for data at rest is now GA. We also added, like in the previous demos you saw, we were providing configuration with SaaS keys. Microsoft preferred way always is through OAuth, by integrating it with Azure AD. So Active Directory, and we support this now. You can use OAuth bearer tokens for Kafka applications too. So both SaaS and OAuth is supported for Kafka now. We also launched a partition scale out. So you can now dynamically add partitions once your topic or event hub is created. Since we again have a standard under stringent quotas where you cannot go beyond 32 partitions, it made more sense to provide this feature onto dedicated. So today it's available only with dedicated. And there is an article which explains how your clients are going to behave, what are some of the things that you need to take care of when you're scaling out your partitions. VNet private link support, this is also supported. Now, with this, there are various questions that's being arising, what about the first party trusted Microsoft services, like, my VNet is enabled, what about VNet on Stream Analytics? So all the support that event hubs needed to do to support the first party is done. So it's twofold. One is that the support that we provide, and next the first party itself need to provide that support to plumb this whole line. So Stream Analytics and services like Stream Analytics, Azure Monitoring are continuously working towards bridging this gap. And when they enable VNet capability on their end to trust the first party, this entire end-to-end can be seen working. So we are also targeting for June a bunch of things. Our extended retention is going GA. This is it's available in very few regions, but it's pretty soon going GA in all regions. This is extending the retention beyond 7 days on dedicated only. Our standard comes with 7 days retention free. This is extended only on dedicated for customers who need beyond 7 days. We also did a public preview of Event Hubs for Staff. We are looking forward for GA now. We would soon be doing a public preview of Idempotent Producer. This will be supported for the Kafka scenarios first, and later in fall, we will support Idempotent Producer for Event Hubs, native Event Hub scenarios too. So the biggest thing that's coming in June, in next week, probably, hopefully, is the public preview of Schema Registry. Now, Schema Registry is a concept wherein you want your producers and consumers to adhere to a contract. And that contract is the Schema Registry, where you don't want each message to carry the schema itself, but then have a repository where both producers and consumers are referring to that particular registry, and they carry that schema along with the message to their downstream processing. Now, the private preview of Schema Registry is coming next week. Any customers interested, please reach out to us and we can get you onboarded. We are planning to public preview the Schema Registry by fall. Another interesting thing that's coming in fall is the public preview of premium EHQ. Now, we saw standard SKU, we saw dedicated SKU. We saw standard stops at 20 Mbps, and dedicated starts from anywhere greater than 50 Mbps. Now, we saw a huge gap. We are seeing a huge gap, and we have a lot of customers asking, can I have a middle tier where it's not the quotas are not enforced as stringently as what is in standard, but I don't want as big a SKU as dedicated. Yeah, we heard you, and we are soon going to launch the public preview of premium SKU. Sorry for the typos here. Now that will give you all the features, or most of the features, most of the potential features that you will see in our dedicated SKU. It will be built on an isolated model. Standard is completely multi-tenant. This is multi-tenant but isolated, so you still get the resource. It it's a resource-based model, and it will overlap standard and dedicated. So anyone interested in knowing what this queue is, what it's capable of, please feel free to reach out to us and we can provide you with more information. Apart from that, we also plan to GA log compaction and Kafka Connect support. Today, Kafka Connect is in preview, and we plan to push that out to completion. We also, in last year, we launched a self-serve of, cluster management, where you can go to the portal and create your cluster, create your dedicated cluster by click of a couple of things. So that's not full-fledged. You can just today create a cluster and monitor the cluster, but we are making it full-fledged, where we want to introduce scaling, we want to do a complete management, provisioning, everything. So that's coming up. These are the big items that looks like what we would be investing in for the rest of the year. As I said, these are tentative. Like these are our desired timelines, but we never know what things change. So these are tentative, but this is how our investment is going to grow. I'm not going to talk about this because these are still far ahead in the future, but at this point, these are a couple of Event Hub's resources for anyone to refer to our GitHub, our samples, or any questions that you have, and how to reach out to us. That's all I had from my end. And I'm open for question and answers. Any questions?
So Shubha, there are a couple of questions. I can read it out for you.
Yeah.
The first one is, do out-of-box Kafka connectors work against Event Hubs both as sink and sources?
Yes. So what Event Hub supports is a Kafka Connect framework. Now, out-of-box connectors, most connectors are, if it is owned by someone, or let me say, we do not host the connectors. What we provide is a framework that can help you connect the sink and sources. So out-of-box connectors, if they are using the Kafka Connect framework alone, yes, it should work.
Okay, next question is, does Azure Event Hub for Kafka match the performance and scalability levels of Apache Kafka? Are there any limitations?
So Kafka is a software, and you can bring in a big compute and then test it. So testing Kafka from benchmark perspective is completely dependent on the infrastructure that there is. And that's where what Event Hubs is capable of is what our benchmark on dedicated clusters show you. If there are specific benchmarks that you're trying to, specific benchmark tests that you're trying to do, you can reach out to us and we can discuss, what is possible, what's not possible. But I would go from the price perspective. For the 5K cluster that you get, if you are capable of doing 5 MB, 100 MB per second, that's how I would reach the performance of Event Hubs. It's not different. There is no performance difference between running the Event Hub load or the Kafka load on Event Hubs, if that answers the question.
Okay, the next question is, why auto deflate feature is not available out of the box like auto inflate as its serverless platform?
That's a great question. So let's look at what happens in a streaming platform. So Event Hubs Event Hubs or Kafka provides you a streaming platform with replay, with retention. So messages that come into the platform do not get deleted. They expire over time. And when it comes to deflating, Event Hub service do not hold the service side cursor. It's always the client side cursor. So there is no a triggering point. There is no way for the service to know a triggering point when to deflate it, because the consumers can consume and we don't know whether they have consumed, whether they'll come back and consume. So if you have any specs that you say, these are some of the triggering points that event hubs can consider to deflate, that would be an approach that we would think. But right now we don't know, because we do not maintain a client-side cursor to say, hey, this is a criteria that we use to deflate. It's very easy on the ingress end, because the traffic is incoming, and then it's trying to push, and then the traffic is trying to push more, and then we just inflate it.
Okay, the last question is from Paul. He asks, what about replaying data?
You can do the replay of data. Today, streaming platform, if you see, you can do the replay of data, and that's exactly what you can. You set an retention period by default, which is 1 day, 24 hours, and you can extend that up to 7 days on standard, or up to 90 days on dedicated. And within that retention period, you can come back and replay.
Okay, that's all I have, Shubha. There are no more questions, and
Awesome.
we're all on time. Yeah.
Cool.
Thank you, Shubha. Thank you for this.
Yeah, thank you all. This was really great. Thank you all for the great opportunity.
Covey.co